In the video that you were assigned, on the first lesson of Unit 8, it's property of logs. It's probably the easiest lesson you've seen in a long time. So we are going to expand this. This is in condensed form. When we expand it, we turn multiplying into addition. We turn division into subtraction. And if there is an exponent, the exponent comes out front. So you're going to watch me go through and do these very quickly. This is log base 2 of 5 plus log base 2 of 3. As simple as that. We are just expanding it. There is an exponent here. I'm going to throw in front to have log 2 times log base 7 of 3. Here we have division. Division turns into subtraction. Log base 5 of 27, subtract log base 5 of 4. These are all being multiplied, so I have log base 12 of x plus log base 12 of y plus log base 12 of z. Very simple. Now this is a little more complicated. Hopefully at this point you can see we have a trinomial, and this trinomial can be factored. What multiplies to give us positive 9 and combines to give us 6. That'd be 3 and 3. So this simple trinomial is going to factor into x plus 3 and x plus 3. So if I rewrite that before expanding it, it is x plus 3 quantity squared. And so I'm able to take this square and pop it down in front. So when I expand this, this is 2 times log base 10 of x plus 3. This is a little more complicated because now we have cube roots involved. So these first two are going to be added. So I have ln, whether you write it as ln or log base e, that is up to you. So ln of x, and the exponent goes down in front. Using this rule, if we have an exponent, it's going to be thrown in front of the log. So, and then we're going to add that because it's being multiplied. Now I'm going to rewrite this as y to the 1/3. That is equivalent. This is rational exponent form. That is equivalent to the cube root of 3. This is in radical form. This is in rational form. They are equivalent. The 1/3 comes down in front, and I have 1/3 ln of y. That's the top part. Now from that, I'm going to subtract, taking the 2 down in front, 2 ln of z. Let's look to the bottom. Now, again, this seems very simple. The only difference is I have 2 items on the bottom, and I'm going to show you how it'd be easy to make a mistake. Log base 3 of a, and the 5 goes down in front. That is the numerator. Now I'm going to subtract the denominator because division turns into subtraction. So I have log base 3 of b plus log base 3 of c, and the square goes in front. Lastly, I need to distribute this to both items. Inside the parentheses, I have 5 log base 3 of a, subtract log base 3 of b, and now when I move this over and distribute, I get subtract 2 log base 3 of c. Very last one. What number is hiding here if you don't see a number? Does anybody remember? It is a 2. It is a 2. If you did not know this, maybe you want to write this down. These are equivalent. The square root is equivalent to x to the 1/2. The square root is equivalent to x to the 1/2. So before I try to expand this, I'm just going to rewrite this. Now when I rewrite this, this 2 always goes on the bottom. It doesn't matter what number is out front, whether it's a 2, whether it's a 3, it's a cube root. This value goes out front, and in this case, the 5 would go on top. Now when I rewrite it, the exponent goes in front, and I have 5/2 times the ln of x. Oh, instead of going from previously, we went from taking this in to expanding it. Now we're going to go back to condensing it, putting it together, but we're going to apply the same 3 properties we talked about at the beginning of class. So in this situation, I know that addition is going to turn back into multiplying. And if I have a number out front, it's going to become an exponent. When I rewrite this, I'm going to draw an arrow here. So I have log base 7, and I'm going to have 2 to the 3rd times 3. 2 to the 3rd times 3. I know 2 to the 3rd is 8. So log base 7 of 8 times 3. And I believe he wants you to even go one step further. Again, this is okay for me, but one step further to 24. I will check how far he wants you to go based on looking at an answer key. It looks like he does want you to take it one step further and actually multiply it. Okay, same thing. I'm going to draw an arrow here. Anytime I see out front where I see an exponent, I have log base 8. Now, this is 36 to the 1/2. 36 to the 1/2, as we showed just previously in the earlier part of this video, Anything to the 1/2 means a square root, because you're asking yourself, what times itself 2 times gives you 36? And that would be 6 times, I'm going to draw a little arrow here, what times itself 3 times gives you 27? 3. And now we have log base 8 of 9. Same thing here. What times itself 4 times? What times itself 4 times equals 625? That's a little bit harder. It is 5. 5 times 5 is 25. 25 times 5 is 125 times 5 is 625. So this is 25, but now subtraction, as we can see up above, subtraction, going back into condensed form, turns into division. We cannot divide these. That would turn into a mixed number. We don't do that, or a decimal, so we leave it just as is. Okay, when I see 2 negatives back to back, I know that this really was log base 13x plus, sorry, there's a subtraction here. This is a subtraction, and then it was log base 13y plus log base 13z. Because this division, as we saw in the previous, earlier in this video, gets distributed to make a negative log base 13 of y and to make a negative log base 13 of z. And hopefully that will help you as we go through this. So I have log base 13, okay, x is on top, and now subtraction really turns back into division. And I have log base 13 of y times z, y times z. Very last one. When I take this and I make it the exponent, I have a couple ways I can write that. One is the cube root. This is equivalent to the cube root when I put it back into this form. Another form that would be a cube would be similar would be up here as a 1/3. Okay, up here as a 1/3 is a rational exponent, or in radical form it looks like this. This is the exact same concept that we have up above. So I have log base 7. Okay, this is going to be on top, x plus 3. Now on the bottom, when I have 2 negatives back to back, that really was subtract, and in between here was addition. And when I distributed it, it became 2 negatives. So on the bottom, I have x times x minus 1. And when I distribute, I end up with the cube root of x plus 3, log of 7, x plus 3, divided by x squared minus x.